Hey guys, Lard here. In this tutorial we will improve our AI targeting and the way that AI moves towards us in our lightsaber combat project. Okay, so we're also getting a lot of so we're getting overlapping with the AI's capsule, and you can see the result of it. Kind of looks funky. So sorry, so this is the first thing we'll fix. Let's go ahead and look at our AI, or actually, no, let's look at lightsaber thing. So let's go towards our lightsaber thing. And lightsaber does line trace by channel visibility. Okay, great. So the only thing we need to do now is go to our third person character bot. And then here we look at our vision sphere, which is exactly the problem. It overlaps with the lightsaber line tracing. And because of that, we will go ahead and first of all, we have our overlap only pawn selected. Now here you can press custom and then manually modify stuff. So here I will modify the line trace to visibility to be ignored. You could instead, for example, go ahead and lightsaber and change the trace to camera, but I will try that. So let's see if it helps. And it does help indeed, and everything else works as it should. Okay, so I had some comments on my previous video about how the guy will always be behind and he will never be able to get to our coordinates because he will always be trying to catch up. And again, this is the reason for this is that I didn't want to make the video overly long. So in this video we will tackle this problem. And the first thing we will tackle is actually how we store the target. So we store the target here in our third-person bot character blueprint, and that's not usually the way you want to do it. The way how I approach it is if we go to LCCBB, which is our Blackboard for our behavior tree. Remember, Blackboard is kind of like a storage, runtime storage for the behavior tree. So behavior tree can take values from here and store values in here. And you can also go ahead and store values into here straight from the blueprints. So you don't have to only use only do operations on Blackboards from the behavior tree. So we go ahead, we do add new Blackboard entry, and let's make it an object. Let's call it target. And let's just keep it target. Now here at the right you have the key type. Let's put their actor for now. And we'll not change any other parameters. But the important part here is that now if we go to LCCBT, which is our behavior tree, you can see the target entry here. First of all, let's try to store this stuff. So instead of having target here and changing it like this, let's make a specific function which goes ahead and does it for us. So add a new function to the third person character bot. Let's call it set target. Let's add another one and call it clear target to kind of mimic our functionality in the begin overlap and end overlap. So how does set target work? Well, the way how you access the blueprint, the behavior tree and the Blackboard is through the controller, because controller actually has the direct link to the behavior tree. That's how we start the behavior tree and run the behavior tree. So we go ahead and we say get AI controller, and control actor is this guy. So this is a handy function which assumes that we are governed by AI controller. And in our case, in case of the bot, we are sure because that's how our game is built, right? So we take our AI controller object reference, and then we just go ahead and do get Blackboard. Now, of course, it is a smart thing to do to check all this stuff. You know, is it valid? Is there a Blackboard? Is there a controller? But the cool thing about blueprints is that if there are errors and we are accessing stuff which is not there, we will actually have error messages. And sometimes, in my practice, I found that sometimes it's smarter to not check anything when you are developing and just go ahead and write the code and look at the output log and see, okay, this stuff is not there, so it's a good thing that I'm actually, you know, looking out for this error, because then I can fix it in the code. In the production, of course, it makes more sense to check and have failures, like all the failure cases or most of the failure cases covered, unless you have a really good API with the error propagation and everything. Okay, so set value as object. So you get value as object from Blackboard, you set value as object from Blackboard, same way. So the key name is easy. It asks for fname or name. This is a special type in Unreal Engine framework, which is really fast to look up. So it's faster than string to look up. And I think it's not case sensitive as well. So we do make literal name, and we remember that we called in the Blackboard, we could just call it target. So we go ahead and we make literal name target. So the object value obviously goes here. This is the cool thing, in case you didn't know. You don't need to fill in the inputs for the function when you're creating function. You can just make it like this and then connect here. So I dropped it on top of the set target node. Now there is one thing about this, is that set values object sets objects, and now this thing is object. We want it to be at least an actor. Let's pretend that we can target actors, not just characters. So let's call it new target, right? And so new target becomes this guy. And similarly, clear target will be also pretty easy. You just go ahead and you do clear value. As simple as that. Clear value just makes it kind of null. And again, you can just copy paste this thing right here. So now we go back to event graph and we have set target and clear target. And this becomes the target, and clear target is just like that. Save, compile. Okay, so let's see if this works before we go any further. Of course, there will be no current target for us, but one thing we can test is that when we are inside this, oops, he went too fast. He's too fast for me, so no, I cannot get to him. Oops, yeah, good. So I paused the game when I'm still inside the overlapping sphere. So now theoretically the Blackboard key should have it, right? So we go to our behavior tree, and you can see at the right bottom we have a kind of debug output for us, which is, you know, it displays exactly what the Blackboard variables are equal to. So target is actually third-person character CO, which is us, and you can see that it's us because automatically Blackboard also stores self-reference or self-actor, and you can see that the guy who is possessed by AI logic is third-person character 477, and the target is CO, which is us, because it's the other character and there are only two characters on the map, right? Okay, so this works. Now we will do a couple of things, of course. We have our event seek with printing. So now what we want to do, we want to print the target. Well, how do we get the target? Well, let's make another function in case we will need to get a target from Blueprint. So get target, right? And the way how we do it is we copy this stuff from here, and we just go ahead and say, you know what, get value as object, and get target is something that has output as an actor output, just like that. And the name, of course, is a target, and we output it. We have to cast it to actor. And of course, right here again, you can have this safe cast or kind of impure cast, as they call it here. And if in case the cast failed, we return null. Or we can do pure cast, and in case you're trying to return null, which was failure as a casting failure, right? Sorry, I didn't want that. In case the cast wasn't successful, but you're trying to return it, it will give you an error. And this again could be handy, just because you will see that you made a mistake in your code. So again, this is kind of like design choice at this stage. Okay, so get target. I will show you something here as soon as we make this thing work. So you can see I call this function and just do the same thing as I did before. Get display name and print it. So let's see what happens. Okay, so it works. Well, actually it doesn't, because it doesn't get reset for some reason. And if I'm away from this guy, let's look at our behavior tree, and we see that the target is still there. Okay, so something is clearly not working. Let's see what it is. Right, because we're comparing to target here. Okay, so here we need to do get target as well. So compare, is it our current target? And then if it is, then we clear. Okay, so now let me show you something. So this get target doesn't do anything, right? It just accesses the variables that currently exist or not. So what you can do is you can make it pure. If you make it pure, the cool thing about it is it doesn't require any execution node, which it shouldn't, because it doesn't do any logic, it just returns stuff. You can also make it const, which basically means that it doesn't depend on any variables on or doesn't change any variables of this object as well, as far as I remember on Real API. So this is good enough for us. I don't remember clearly the difference between const and pure. I think you can have pure functions which still do some execution silently, but if you have const functions cannot change anything at all. So let's just keep it at that. So this is a const function, doesn't change anything at all. Okay, so we have this guy, and then of course we compare other actor to our current target, and you can see the code looks neat because we don't use extra execution nodes. Okay, so have a target, we don't have a target. Have a target, don't have a target. Okay, this is all nice. So what is the primary advantage of having this target in the Blackboard? Well, here's the thing. We have this complex logic, which is, you know, if we have a target, get point near it and then move to it, and AI will always be lagging behind because he has to get to the previous point and he already moved. Here's the thing. If I get rid of all of this, right, I just have move to. In case I have target, I move to. If I don't have target, if this is false, then I go here. And has target, by the way, we don't need as well. We will change it to something that's Blackboard. It's called just Blackboard. And what this thing means, and we change the Blackboard key to target, this basically says if target is set, which is exactly what we do, right? We set the target and we clear the target in case we don't have one. If the target is set, then move to target. And somewhere here there is this track moving goal. Yeah, so I changed two things after I deleted all the redundant code here, redundant nodes, right? First thing I did, I changed the decorator to just be a Blackboard decorator, and that's a native decorator. It's right in the engine, you can use it. You don't have to write any code. So if there is a Blackboard key which you can validate, is it set or not, then you can use this decorator. So whenever target is set, we move to target and we use track moving goal, which is, I will show you what. So let's see. So now you can see he's not lagging behind anymore. And the reason for this, of course, is that, you know, he's tracking all of my movement. Every tick of the engine, he is actually actively tracking where I am. Now he moves there instantly. So it's it's pretty much impossible to get away from this guy at this point. Okay, I managed to do it, but yeah. So we solved this problem and we improved our design. Let's stop this video here because basically we kind of achieved part of our goal. Let's make sure to save everything. And in the next video we will start working with the lightsaber for our AI. So we will light up his lightsaber when he sees us, and we will see if we will have enough time. We will get to the first attacks. So thank you for watching and see you next time.